So today's topic is area of sectors. Whoops, let me take my bracelet off before it messes up everything. And these are notes for 11-2. So this is a sector. Wow, that's kind of cool. I didn't even change that, but look at that. So a sector is essentially a piece of pie. A sector is part of a circle, or you could think of it as a slice of pizza, whatever it is. We're going to find the area of that. We found before arc length using a similar type of thought process that we're going to use today. But today we're finding this area of this pie-shaped region. So a sector what did I put in there? Oh, a sector is a section. I forgot what I put there. Of a circle bounded by a central angle and its intercepted arc. So remember, your central angle is right here. So this x degrees, that's your central angle. And this is the intercepted arc right here. So you come in late and you're disturbing my class. Hurry up. So I want you to think of, as I said earlier, think of a sector like a slice of pie or pizza, whichever you prefer. Yum, 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 right? So again, I don't believe in memorizing, so you're going to learn how to derive the formula. Of course, you're going to write the formula over and over again today. By the time we finish notes, you should have the formula memorized. And then on your homework, you're going to write the formula 10 times because you got 10 problems on your homework, okay? If you look at the yellow sheet that I gave you, on the sheet there for the formula, it has x pi r squared all divided by 360. That's the formula that they use. But let's explain why. If I figure out what portion of the circle this is, and then multiply that fraction by the entire area of that circle, won't I find the area of that sector? We're going to use this central angle right here to figure out what fraction of the circle that piece of pie represents. So if you recall, when we found arc length, didn't we take the central angle, and how is the central angle and the intercepted arc related? What are their measures? Equal or different? They are equal. So whatever the central angle is, that's what the arc measure is. So if you took your arc measure, and how many degrees are in a whole circle? 360. So if you took your arc measure and divided it by 360, wouldn't that give you the fraction that that arc is of the whole circle? And if I took that fraction and multiplied it by the area, I'd have the area of my sector. And so that's what we're going to do. I prefer to write my formula as A equals, I'm going to just put arc here for short. It's really arc measure. Arc measure divided by 360 times pi r squared, that's your area of a circle formula, all over 1. Now, they're using x to represent the arc. You can do that as well, but the problem with that is you have to know what x means. If you learn instead arc over 360 times pi r squared, you're safe. So any questions about the formula? So if you know how to derive it, you don't have to memorize it. So let's go ahead and look at number 1. So number 1's fairly straightforward. We're going to start with a formula. A equals arc over 360 times pi r squared. No talking. Over 1. So we're going to find the two things I need. I need my arc and I need my radius. So they have given me this central angle here. What's the measure of my arc? If my central is 51, Is in my arc also 51? And then in addition to that, they have given me BC is 16. What part of the circle is BC? It's the radius. So they've given me what I need, which is my radius. So I have all pieces that I need to plug into the formula. So let's plug and chug. So I'm going to plug in 51 for my arc measure, and then 16 feet, include those units of measure inside. To make ease on your calculator, if I were you, I would square this first and figure out what that is and write down what you have. So I have 51 over 360 times pi times 16 squared is 256 feet squared over 1. Then this is what you're going to put in your calculator. You're going to do 51 times your pi button, not 3.14, times the pi button, times 256. Enter. And then divided by 360. Then we are going to round to the nearest tenth per the directions. So tell me what you get. $113.9 what? Does the 3 stay a 3 or does it bump up to a 4? It bumps up to a 4. And then you get feet squared. So is that all that hard if you have use of a calculator? Not too tough, right? Okay. So what I want you to do is number 2 all by yourself. So you're going to do 2 on your own. And I'll quietly do it up here while you do it at your tables. Make sure you write that general area formula so that you start to memorize it. Then I want you to discuss your answer with those around you. Are there any tables that there's not somebody at your table group that doesn't have a calculator? Is there any table groups without a calculator? Huh. All right, y'all need to y'all need to bring a calculator. I'm not putting the calculators out on the table all period anymore because you guys take them. And then I don't have enough for testing. So you've got to bring your calculators to school. What? No. I'm not allowed to take your ID for a calculator. Really? Plus that takes time. You be responsible. Bring your own. Okay, so I'm going to start calling on you. See what your answers are. Molly, what did you guys get? .09, right? She's correct. There's the work. So this was the radius, so we just put 22 in here. 22 squared is 484. Show more work, kill a tree, right? And then you just multiplied 139 times your pi button times 484 equals divided by 360, and you should get this. Any issues, problems, or concerns? Olivia?
Why is it not 21?
Because we're rounding to the hundredths place, and on your calculator, give me a minute to get it back up on my calculator. Your decimal was 587.093. So following the 9, here was a 3. So we don't round and then round again. Does that make sense? All right, any other questions? Okay, so then we're going to move on. Would you agree that number 3 is just like number 1? We don't need to do it then. So look at number 4. Number 4, what have they given you here? Is that the arc measure I want? No. So if this arc measure is 126, how do I find this arc measure? Subtract it from 360. So what is 360 minus 126? 234 degrees. So that's your arc measure. Again, you want to make sure that you look at what they gave you. They gave you GH. Is GH a radius or is it a diameter? So fortunately they gave us the radius. They're going to surprise you with a diameter here one of these days. So same thing as we did before, area equals arc over 360 times pi r squared over 1. So I'm going to plug and chug. So put your 234 in. Whoops. I was a little dyslexic on that one. Weird. And then 13 yards for your radius. Square that 13 yards. You get 169 yards squared. And then throw all that in your calculator. So you get 234 times your pi button times 169 equals all divided by 360. This time we have 0.09 what? So you have 345. Is it 0.09 or is it 0.10? Okay, what follows the 0? A 3. So you have 0.103. So what does the 0 stay? Does it stay or bump up? It stays. And so then we have yards squared. Yes, because if they ask you to round to the hundredths place, you have to have two. You're not listening. You have to have 2 decimal places. So even if it were 0.00, you'd have to have the 0.00 in there. So it's a good question. Okay, so then number 5 is similar to number 4. So I want you to do 5 all by yourself. And I'll quietly do it up here. So talk about your answer. $6.60. Where'd you get that from? Oh. So technically you should write 6.60 for number 3, yes. You won't necessarily see the answers online doing that, but that's just a technicality. A little bit, yeah. All right, so freeze. Rachel Moore, what did your group come up with? Do you not have a calculator?
Not okay, right? I plugged in most of it.
Okay, so somebody at your group want to help her out? You guys are listening, not talking. When I'm talking to somebody, you're listening. So does anybody else have a calculator? 224.78. Would you agree with that or disagree with that? Agree or disagree? Agreed. Okay, I agree too. All right, so here's your work for that. Rachel, what'd you plug in wrong?
I put instead of putting 218,
Or 318, you put 218?
you put 310.
Oh, okay. Gotcha. All right, so are we good with that one? These really aren't that bad, are they? Really not that bad. I mean, the pictures look like ugh, but given a calculator, they're really not that tough. All right, so would you agree that we can skip number 6? All right, so let's flip the page. As you look at, if I have to keep hushing you, I'm going to get irritated. I'm just not you personally, just everybody in general. The whole class is chit-chatty. All right, so the only difference that 7, 8, 9, and 10 have from the front is that the radius they're giving you is in a decimal form. Does that matter when you have a calculator? No. So we don't care. So we're going to skip those. Ooh la la, right? All right, let's look at 11. Now, 11 through 16 start to look complicated, but technically they're really not. I want you to talk, well, let's just talk this one through first. So if this is 46 degrees, what do you know this is? So we're going to put a 46 here, which means that the arc measures are also 46, right? Well, we're going to have to derive our own formula, or just think about what the arc measure is. So I could do a couple of things. I can find the area of this sector. Would you agree that these are identical sectors? And I could double it, right? Or I could think of this piece of pie and move it right next to this piece of pie and put it right here, couldn't I? Wouldn't that just make a bigger piece of pie? Couldn't I just look at my arc measures being twice as big? Why don't we think of it that way? So if I'm going to write my formula, I have to adjust my formula a little bit. So when adjusting my formula, I'm going to double my arc times pi r squared over 1. Now if I had 3 sectors that were identical, wouldn't I put 3 times the arc there? That's all I have to do to adjust it. So the only other thing I need is my radius. What is HG? Is that the radius? Okay, so we're good to go. We have everything we need. So let's plug in. So I'm going to put my 46 in here and my 7 centimeters in here. And then I get 92 over 360 times pi. 7 squared is 49 centimeters squared over 1. So now put that into your calculator. So you have 92 times pi times 49 equals, and then divided by 360. So notice I'm using squiggly equals because anytime we round to decimal place, it's approximately. So we have 39 point, and then my decimal is 339. 339. So I keep the 3, and I got 39. Does the 3 bump up to a 4 or stay the same? Bumps up to a 4. And so I have centimeters squared. Was that any more difficult? No. So I want you to do number 12 on your own, using the same thought processes. So you're doing 12. better be careful on this one. Discuss what the issue is. There's a little bit of an issue on this one that's different from number 11. What do they give you? Diameter. So make sure that you didn't put 30 into the formula. Find the radius. So discuss your answer. All right, so discuss that answer. Are you ready? All right, so stop. All right, Brandon, what did you guys get? Chicken livers? Fuzzy navels? Check again? There you go. Those stinky feet. All right, so the answer is correct, is 443.75 feet squared. Any issues or concerns with that? Okay. All right, so let's talk about 13. We're not going to do it, but we're going to talk about it. So here's the issue with 13. They've given you this. We want this and this. How can I find this? I'll be in a what? Not 360, but what's that distance? 180. Very good. So we would take, so write yourself a note that from here to here is 180 degrees. So if you subtract the 143 from the 180, then that would give you this measure, and then wouldn't we do exactly what we did in 11 and 12? So that's the only catch on that one. We're not going to do it. 14, isn't that essentially the same thing? Just really big sectors, right? So we're not going to do that one. Let's talk about 15. I want you to discuss in your table group how you're going to approach 15. Because this time we don't have two equal sectors. So how are you going to do it? So don't solve it yet, just discuss how you're going to approach the problem, because I don't want you to solve it wrong. Are you ready to set it down? Did you write anything down? Christopher. Come on. Right? Those are choices. All right. So let's chit chat. How about Lauren? What'd you guys decide to do? Shh, you're listening. So you added 58 to what? Would you agree to add 58 to 180? Because this is 180, right? And so your arc is equal to 180 plus 58. What does that give you? What does that give you? 238. So that's your total arc measure. So we can still use area equals arc over 360 times pi r squared. So by this time you should know this formula, right? Okay. Jm. Is Jm a radius or a diameter? So that's our diameter. What is your radius? 5 millimeters. So we're ready to plug and chug. So we're putting the 238 in for arc. And the 5 millimeters in for your radius. And so we get 238 over 360 times pi times 25 millimeters squared over 1. Throw that in your calculator. Discuss what the answer is. So you're going to put 238 times pi, your pi button, times 25 equals, and then divided by 360. Tell me what you get, Amelia. 51.9. Is it a 2 or is it something else? It's a 2. What follows a 2? Perfect. So 51.92 millimeters squared. Yep. How did you do with that? Okay, so the last one that you're going to do, and you're going to do it on your own, is number 16. You're going to brainstorm how to find your arc measures. You're going to find them, determine do you have the diameter or the radius, and then plug and chug into your formula. That's all you got to do. All right, so discuss your answer. You shouldn't be discussing dogs and their age. Does everybody at your table know how to do the problem? Okay. All right, are we ready to discuss? All right. Hush. All right. Grace, what's your answer? Because your table group left you behind, didn't you all? You wanted to discuss the age of a dog. All right, Joe, what'd you get? 218 point what? I can't hear you, dear. You got 226. What did you get for your arc measure? That's why. So your arc measure's off. So the 62 This is 62, 62, and 62. I know that they're all equal because of these marks right here. I don't necessarily know that these are equal, by the way. At all. So all I did was take 360, the whole circle, and subtract out those 362s, right? And that should give you 174. So your arc measure should be 174, so that's probably where your biggest error might be. And then this is the radius. PC is a radius from P to C. So 12 goes in there, squared is 144. And then when you multiply those together and divide by 360, you should get 218.65. Any issues there? Okay.